for introduction to you. And it's coming up now, right, Kitisak? Yes. So he's one gentleman who do everything from taking photo, that is Princess Churapon efficiency. Going to be displayed, right? Okay. You can use my mouse if you want to. Today we are learning new technology too. Right, so I just want to show you. Right, this is my introduction to you, Matt. And sorry, I have to remove the chair because I know you won't need it. Now I'm going to test a student. If you understand my English, you will understand Dr. Arthur Gawker. If you understand my English, raise your hand. Excellent. There's no need to speak in Thai anymore, but you can try some. You see the slide. This is a slide I use about 400 times during my time at KVIS and now at Vistech with Moji, you senior from Princess Churapon, Chonburi. I showed this slide because Dr. Arthur Gawker is a friend of Thailand. He loves Thailand very much, and he wants to help Thailand. Very nice. Very quiet. That's excellent. I want to say this because Arthur told me once. No, at first, the president, the MC told you already, Dr. Arthur Gawker, he was born at the same place as Nikolaus Copernicus at a town named Torun in Poland. And you know why? I have checked with you already this morning, and you know Nikolaus Copernicus quite well. This gentleman used the same playground as Nikolaus Copernicus. That's what he told me. But the time difference is 400 years. Understand? See some smile, I mean you understand my English. And the one I want to say it here, Arthur told me, Thailand is a good example for other countries. Thailand is a good example for other countries. Who did? You agree with me? Very good. He agreed already. That's very nice. But at that time, I wonder whether Dr. Arthur want to just please me because we are good friends, right? He said no. He came to Thailand many years ago, since King Rama IX was still with us. And he told me every year he saw that picture, yellow flag everywhere. And he asked me, I have been to several countries in the world, UK, USA, Canada, Australia, Japan, Korea, France, Germany, and haven't been to Poland yet, but in the future I will go. He asked, you have been to many countries. Have you seen anything like this? I said, no. So he said, you're lucky. You have one person, spiritual, who hold the nation together. Now, every people look up to him at the balcony there. So your country is so lucky because you told me you haven't seen any countries like this. That's why Arthur said, Thai เป็นแบบอย่างที่ดีสำหรับหลายๆประเทศ Thailand is a good example for other countries. I agree with him. That's why I was so proud of my friend who told me this, and I got a chance to show this slide to everybody. I think now more than 100,000 people who went to the Wangchan Valley. So I'm so proud and happy so much that he volunteered. Volunteer แปลว่าอะไรลูก Correct อาสาสมัคร That's what I mean. Volunteer, they understand English very well. Volunteer to give this special lecture to you. So, Kititat, I will hand the screen to you to project the slide of Professor Arthur Koka. So Arthur, thank you so much. I appreciate that for me to be able to show that slide. About 100,000. So this is yours.
Thank you very much. ขอบคุณมากครับ Dr. Tan Action to Ajahn Talk for invitation. Come here today. That is a great pleasure and honor to be here. And I love to be with students like you. สวัสดีครับนักเรียนสบายดีไหมครับผมพูดภาษาไทยได้นิดหน่อยผมชื่ออาร์ตกอร์คาผมสอนคณิตศาสตร์ที่ Erskine College รัฐ South Carolina ประเทศอเมริกาผมเกิดที่โปแลนด์เมืองทอรุณประเทศโปแลนด์และทอรุณเป็นทอรุณบ้านเกิดของ Nikolaus Copernicus ผมจะพูดที่ของ Nikolaus Copernicus วันนี้ผมจะพูดที่ Nikolaus Copernicus เข้าใจไหม Okay. Thank you very much. I will not continue in Thai because it would take probably 10 hours. But I will try to say something about Copernicus today and tell you about the mathematics that we know today. How do we know it? How did it become a subject that we should know? And how mathematics can be used in our everyday life. Nikolaus Copernicus is one of those people who used mathematics to change the view of the universe, of our view of the universe. So we'll have a little bit of history and mathematics today. I hope that you are going to enjoy the journey with me. Thank you very much for listening and being here. Any Star Wars fans here? I love Star Wars, and I have a collection of all the DVDs of Star Wars at home, and I watch this from time to time. So our story begins in a long, long time ago in a galaxy that is not that far away. It is called the Milky Way. Do you know the Milky Way? It's a nice, average-sized spiral galaxy in the universe where we have 100,000 billions of galaxies. Each galaxy, like our Milky Way, has about 100 billion stars in it. And we are just on the outskirts of this galaxy, about here. Okay, here. There is a average size star is called the Sun. Just one of the 100 billion stars in our galaxy. Sun is one of them. And around the star, there are 8 planets moving around. And one of these planets is blue in shape when looked from the outside, and it's called the Earth. The history of Earth is about 4 billion years. Earth is about 4 billion years old planet that has gone through an evolution. You probably know the stories about dinosaurs, and you may have seen some nice movies about dinosaurs. They were roaming on this earth here 100 million years ago, but then some cataclysm happened. We are thinking today that there was a meteorite that hit the earth and they disappeared from the surface of the earth. The only things that survived were mammals that evolved, and then some of these mammals became humans. And there were civilizations of different kinds. About 10,000 years ago, some civilizations started showing up, building structures like homes and temples. And you probably know about the Chinese civilization. You probably know the Hindu civilization. You probably have heard and learned in history classes about Babylonians and Egyptians. And about 4,000 years ago, the dawned civilization of Greeks. And they were wondering how things were made. They created a beautiful story about creation of Earth. They said that it was chaos at the beginning, and then out of chaos, Gaia was created, the Mother Earth, and Eros, the god of love. They procreated and they gave birth to Titans and Cyclops and many other gods. And the 12 gods of Greece were living on the Mount Olympus. Are you familiar with Zeus, Poseidon, Apollo, Aphrodite? Any of those sound familiar? That's part of the Western civilization, so maybe you have not heard about this, but you probably have seen some interesting movies about the gods and titans and others. They are based on those interactions. These gods, they had supernatural powers. They could create things they could let the rain fall on earth. They would make sunshine, and they would sometimes be happy and make people happy, or sometimes they would create unhappiness and wreak havoc. They would destroy things. People didn't have a way of dealing with that, but they had to somehow explain what happened. So they attributed everything to gods. Anything good, anything bad was due to gods. So that was a good explanation for them. And that's the myth, the mythology of Greece. About 700 BC, the Greek civilization, brought some wonderful thinkers, people who were able to observe, take note of things happening around them, and they started looking for cause and effect. The Greeks was the first civilization that started explaining things by reason, by thinking. They stopped thinking that there were gods responsible for everything. They thought that there was some rule causing all of that. And they were trying to find these rules. They were using logic to deduce things. They created reasoning rules. They were the ones who said that if A happens, then B must be. They were using this reasoning not only to find things, but to prove things. Do you know what a proof is? A proof is a sequence of steps that we show from A to B, from B to C, C to D, sometimes many steps, and we show that something is true for all possible. The Greeks was the first civilization that created a proof, mathematical proof. Some of these great thinkers here that we will look at in greater detail in a moment was Thales of Miletus. It was the first mathematicians that we have a record of that was using this reasoning rules for proving things. Pythagoras of Samos, there was another great mathematician that you probably know. Does anybody know here Pythagoras? Pythagoras theorem? Do you know that? We'll see that in a moment. And Aristotle, he has created a universe system, the idea that would explain how things happen. Aristotle that lived in 4th century BC, which is 500 years ago. The gods lived on the Mount Olympus. And every 4 years, the Greeks compete in something that we know even today, Olympic Games. Olympic Games are held every 4 years, and I'm sure that some of the Thai athletes are also taking part in that event. This is the biggest events in sport. Now, the first Olympic Games were held in 776 BC. a place, there was a stadium. Olympians would come there with each other. So that was their way of showing who is the best. They were not only thinkers, but also athletes. They would love to have good mind, good spirit, and good body. So one of those athletes who was really a very man was Alexander the Great. He became the leader of the Greeks, and he expanded the Greek empire all the way from the Greece, which is about here, this Greece. I don't think that my pointer works, but Greece is here, where the Greek civilization started. And Alexander the Great expanded the empire to Asia Minor, which is countries of Turkey today, Syria, of Babylonia before, all the way to Egypt. They would set up their cities and settlements, and they would teach all these people the ideas that they were thinking about. They brought the idea of reasoning and proof all these countries. Now, all that part of Asia here, it was the part of the Alexander's empire all the way up to India and maybe even close to today's Thailand. That
Dr.
is
Arthur,
how big that empire was.
just a quick interruption.
Yes.
I'm sorry. นักเรียนชักมีเสียงคุยดังเยอะละกำลังจะบอกว่าอย่างนี้นะ เดี๋ยวพอจบเลคเชอร์จะมีคำถามถามจากที่อาจารย์เขาบรรยายเนี่ยนะครับฉะนั้นเวลาฟังจดไปด้วยเพราะนี่เป็นประวัติศาสตร์ที่น่าสนใจมากเลยเธอจะอย่างน้อยเธอได้เข้าใจว่าทำไมแข่งโอลิมปิกทุกๆ4 ปีเข้าใจแล้วใช่ไหมสิ่งเหล่านี้เป็นประโยชน์มหาศาลเชิงประวัติศาสตร์และต่อไปจะเป็นทางวิทยาศาสตร์ฉะนั้นขอให้ตั้งใจฟังบันทึกไว้ด้วยวิธีไหนก็แล้วแต่แล้วนอกจากมีแบบฝึกหัดแล้วเดี๋ยวจะมีคำถามตอนสุดท้ายครูจะถามเองแล้วครูจะจี้เฉพาะคนเลย Just want to give them that all these things are beautiful story even they myself now too why we have competition for Olympiad every 4 years because it started every 4 years then you know I told them this is a beautiful history and then we'll move to mathematics and science so I asked them to pay good attention and at the end apart from all these exercises I will ask them individually what you have said
There will be a quiz coming, okay? Please take good notes. So that is how the Greek ideas spread around the world. And that's why this Hellenistic civilization is also known even here. But going back to Greece, original Greece, I would like to say a few words about some of these mathematicians that we even cite today. We have their theorems called by their names. Pythagoras' theorem, that's one of those that we have mentioned earlier. And Thales of Miletus, he had also proved a number of theorems that we'll see one in action. Plato was one of those who established the first university, the first school that was dedicated to learning mathematics and liberal arts. In those days, liberal arts was mathematics, everything about the world, as well as music, poetry, studying properties of objects, learning about how things work. So Plato, this is 4th century BC, established the first university. And Euclid was one of those pupils from that university, one of those students. And he has written everything that the Greeks knew about mathematics. Euclid has created a book, a textbook, that had every single theorem of mathematics that the Greeks knew about in it. That was a book that was studied until the 19th century even. So that is something that maybe you can do as well. Maybe you can make a discovery and do something that people will talk about, read about for another 2,000 years. That's what Euclid did. His book, The Elements, has been the source of mathematics for over 2,000 years. This was the textbook for mathematics, Euclid's Elements. So that was the Greek scribe. He did not invent everything. He just wrote everything that the Greeks like Thales and Pythagoras discovered before him. So the Greeks were wondering about a few things, and all of that mathematics was made up based on these ideas that they wanted to find out how to do things. Squaring the circle. Squaring the circle. That was a problem where they wanted to find the dimensions of a square that would have the same area as a given circle. Today, that's not a big deal. I'm sure that everybody of you would be able to do it. Right? If we have a circle of radius r, what is the area of that circle? Pi r squared, which is pi. Pi times 1 squared is pi. So what is the dimension of the square that would have the same area? Square root of pi. Very good. Very good. The Greeks didn't know square roots. So for them, that was a difficult problem. But that led to discovery of math. Another problem was doubling the cube. What are the dimensions of the cube that will have the volume twice as much as the original cube? Okay, another problem was how to trisect an angle. They didn't have a protractor. They didn't have a compass that we could use to copy an angle. So that was a big problem in those days. They wanted to know the dimensions in a triangle. What are the side lengths and angles? So these are some of these problems that led to mathematics development. All these problems were practical problems. They needed to build structures. For that, they know the angle, elevation. So they create triangles to describe that. They needed altars in their temples that would have a precise size. That's why they wanted to know mathematics, how to do that. They were using math for their practical problems. But not only that, they were proving that what they found out was a big thing. Let's have a look at this simple question. It was a quiz question. One of the students was asked to find x. This is what the student wrote. There it is. There it is. So that is not what the teacher was asking for, really, but that was a correct answer. Find x. Oh, here is x, right? But the teacher really meant what is the value of x, right? But this is one of the applications of math. We use a letter to describe a quantity. And this quantity can vary from one unit to another. So what we need to do is to find out what are the relationships between the sides of the triangle. And I believe that you have some printouts in front of you. Okay, so let's find out what this missing x value is. I have prepared here a little bit of a few pieces. Have to assemble as you are asking activity number 1. Okay? One set is per group of 3 students. I would like you to work as a group of 3 students together and answer these questions. Okay? So here's one. I'll ask one.
นักเรียนกำลังดีนะครูเห็นนักเรียนเริ่มสนุกแล้วเราอินเทอร์แอคทีฟนี่ดีถ้าอาจารย์ก็ถามอะไรก็กล้าพูดโดยตรงเลย yes อะไรพวกนี้นะที่เธอกำลังทำอยู่
You have to. And the blue piece. So this activity is an activity where you have to create these 3 squares. The yellow square, the green square, and the blue square. From those pieces that you have, please just cover these spaces that are printed out on your handout there. Okay? Just assemble these pieces in the same way as the handout shows there. Can you do it? Okay? Obviously, yellow and green are easy, right? Anybody has a problem with yellow and green? If you have a problem with yellow and green, please raise your hand. Good. Please assemble the blue pieces into a blue square. Good. Good. No. You assemble them here. Okay? That will be the next part. Put this one, and these ones here. They have to fit, the blue pieces have to fit into the blue square. Okay? Please make sure that you fit the blue pieces on the blue square. Okay? Cover the pieces on the handout with the pieces that you have in hand. Yes, excellent. Very good. Yes, these pieces have to fit here. Oh, you don't have the you need to assemble these blue pieces into this one square of the blue pieces. The blue pieces fit here. Beautiful. Well done. Yes. Please assemble. Put these pieces here. This one comes here. And these have to fit here. Good job. Very good. Yes. Can you cover these pieces here? Very nice. Good job. Excellent. All right, so it looks like nobody had a big problem with that. Wonderful. So, what do we have here are three squares. One which is yellow, another one which is green, and another one that is blue. Please note that they are squares that are on the sides of the right angle triangle here. If that triangle has sides with lengths A, B, and C, please tell me what are the areas of those squares? What is the area of this square? C squared. What is the area of this square? B squared. And the area of this square is A squared. Very good. That's exactly what we have. We have created squares with these areas on the side of this triangle. So, the area of the blue square is B squared. The area of the green square is A squared. The area of the yellow square is C squared. What I would like you to do now is the second part of this activity. This time, please fit the green and the blue pieces onto the yellow one. Okay? Create the blue and yellow pieces onto the green one. Great. That's perfect. Right. Two. Good job. Good. Nice. Very good. Great. So now use these two pieces, fit onto that. Okay? Rearrange the yellow one. You put, will they fit there? Beautiful. Yes. Very good. Rearrange them, fit in here. Good one. To use. good. Yes, that fit perfectly. Right. Very good. Great. Very good job. Here, the answers, and fill this and paste. Okay? Very good. Yeah. Okay, so what we have done, and I've seen most of you got there already, we have reassembled the pieces of the blue square on the yellow one here, 1, 2, 3, 4. We put the green square in the middle here, and it fit perfectly with the yellow screen. Would you agree with that? Absolutely. I like that. That's exactly right. So look at this. A squared, A1's area was A squared, A2 area was B squared, A3 area was C squared. So now these two pieces, A1 and A2, fit into A3. So what is the area A3 equal to in terms of area A2 and A1? What is it? It is the sum of these two areas. But that is C squared being equal to A squared plus B squared. So, can you agree with that? Do you agree with that? Why do you agree? Because you have just proved it. Well done. Give yourself a round of applause. Very good. Very good. That is exactly right. We believe it because we have proved it. Right? So this is the idea of the Greeks. They proved it. Okay? So did you. Well done. Well done. So that's activity number 1. I hope that you enjoyed it. That was a simple one, but some more complicated ones are coming. So please bear with me. Okay? Now, this is Pythagoras' theorem. Pythagoras is a Greek mathematician, and they proved it in the 3rd century BC. But please look at that. That is a clay tablet coming from the Babylonians. Babylonians was a civilization that lived before Greeks. About 3,700 years ago, 2000 BC, they already knew the Pythagorean triples. The Babylonians knew the Pythagorean relationship. So why do we call this relationship Pythagorean theorem, not Babylonian theorem? The Babylonians knew Pythagorean triples. This is clay that is about that clay tablet that is about that big, and it has the Pythagorean triples written on them. They knew it. Why don't we call this theorem Babylonian theorem, but Pythagorean theorem? Does anybody have any idea, suggestions? Why don't we call it Babylonian theorem? a squared is equal, a squared plus b squared is equal to c squared? Because what did he create? But Babylonians knew about it too, 2,000 years earlier. Pythagoras proved it. Babylonians guessed it. They knew about it, but they didn't know why does it work. The Greeks proved it. So that's why we call it Pythagorean theorem. Okay, so that is how mathematics is really done, by proving things. We may get an idea that something works, and then we have to test it. And that's what Babylonians did. They found a few numbers and said, oh, this works. How nice. But the Greeks asked the question, is it true for every possible triple? And they proved it. That's why we talk about proofs of Pythagoras. So this is really true about Pythagorean right-angled triangles, that c squared is equal to b squared plus a squared. And this is really meant by the areas of those squares here. So in our puzzle that our smart Alec answered a moment ago, a squared plus 15 squared is equal to x squared. So x is
เสียงคุยเริ่ม
17.
ดังแล้วฟังก่อนเดี๋ยวค่อยคุยกันนะเดี๋ยวพอมี activity ใหม่คุยกันได้ Thank you.
Okay, so the correct answer would be that x is 17. And how do we know this? Because we use what we have proved earlier. So we know that this is true. We believe it. Right? Who believes that x is 17? I do. Who else believes that x is 17? Just a handful of people? We have proved it a moment ago, that it must be true for all x's. So that is why we believe in that. Okay? So these are the triples. These are the Pythagorean triples. Euclid, and this is his book, one of the printouts, not from 2,000 years ago, but more recent one, maybe from about 15th century. But he discovered a lot of properties of those numbers. Find Pythagorean triples. That's a story for another presentation, maybe in the future. But I would like to spend a few moments about Pythagoras of Samos. He has created the first high school where people were learning about mathematics. It was called Pythagorean Brotherhood. They would ask people who wanted to learn how to prove things, and they were studying things together. They were the ones who learned how to prove things, how to explain things. Pythagoras established this liberal education where he believed that if you can understand mathematics, you can explain the world. We can use mathematics to explain things. This is how this all started, really from Pythagoras. So, Pythagoras followed by Plato, who created a university. If you think Pythagoras had kind of a high school like this school, beautiful school here, and you could be the students of Pythagoras. His pupil was Plato, and he created a university in Athens. This is what was written at the gate of that university. This is in Greek. And it means that no one who knows mathematics cannot enter here. This is what they meant about math. They said, in other words, say today, math rules. Right? Math rules. That's exactly what the Greeks were thinking as well. So this was a beautiful way of showing things. By the way, in Euclid shows that this area of this rectangle, of this square is equal to this rectangle area, and this square is equal to this rectangle area. That's another proof of Pythagorean theorem that was in Euclid's Elements. So we are going to continue our story and move a little bit more to Thales of Miletus. He was one of the first Greek mathematicians that used proof, and he was also an engineer and a philosopher. He traveled to Egypt and he learned geometry there. He established the idea of reasoning, and he proved himself a number of very important theorems that we learn today in geometry about. He proved, for example, the one that if we have a semicircle, the diameter of the circle, and a triangle that is inscribed in that semicircle is a right. Did you know that? Yes, this is something that we learn in geometry today. That comes from Thales. Thales has found out that if we have two lines intersecting, the two angles, the pair here and the pair here, are the same. They are congruent, the same size. That's from Thales. Did you know that? You learn about that in geometry, and this is coming from Thales. Another thing that he proved also was the similar triangles. If we have similar triangles, the same shape, but not necessarily the size, then the ratios of the corresponding sides is the same. Do you know this theorem? It comes from Thales. How about that? So he has proved a bunch of these theorems, and when he traveled to Egypt, he was amazed by this huge pyramid of King Khufu. This is a structure that was built 2,000 years before he came there. It was standing there in the desert as the highest man-built structure for over 4,000 years. This was the biggest structure that the humankind created for over 4,000 years. The next structure that was taller than this one, do you know who was that? What was that? Eiffel Tower. Eiffel Tower was a little bit taller than that, but this is the end of the 19th century, right? The beginning of the 20th century. So the Great Pyramid of Giza was the tallest structure for 4,000 years. And Thales was amazed at that and admiring the skill of those engineers who had built it. They had to use some incredible tricks to make this structure. Actually, I'll tell you a side story. In my calculus class, we learn about Pyramid of Giza, and we calculate how many people had to build this pyramid and how long did it take? Using calculus. Today we can use integrals to calculate how many people built that pyramid and how long did it take. Would you believe that? That's mathematics in action. Okay? So, but coming back to Thales, he was wandering around this pyramid and was asking, how tall is this pyramid? And nobody knew. People didn't know how to find the height of this pyramid because it was slant. This length, obviously, is not the height. The height is from the center of the base to the top. So, but nobody knew how tall that pyramid was. So guess what? Thales found it for himself using mathematics. Yes. So that's what we are going to do. We are going to do exactly the same thing as Thales did, using similar triangles. This is the second page of your handout. Please turn over, and in your groups of 3 people, please work together and find what was the height of that pyramid. Now, here's a little bit of a background story that you may or may not know. So I just would like to make sure that everybody's clear. If we have similar triangles, they have the same angles, but all right. But the sides have different lengths. But one thing is constant, the ratios of the lengths. The length of this side to the length of this side is the same as the length of this side to the length of this side, and it is the same as the length of this side to the length of this side. The ratios of corresponding sides are equal. So here we have this theorem in mathematical terms. Here's what Thales knew. He knew that the length of the base of that pyramid here at the very base, from one end to the other end, that was 500 cubits. A cubit was an ancient measure. It was about the length of your elbow, about a little bit less than half a meter today. So this was how they measured the length, cubits. The length of the shadow of the pyramid was 230 cubits. The height of the Thales' stick that was carrying with him, he was carrying that stick as he walked through the desert. The height of that stick was 4 cubits. So that's 4 cubits. And the length of the shadow of the stick was about 6 cubits. In this activity, you are asked to find similar triangles here, mark all the given quantities on the diagram, and then find the height of that pyramid. Mark the height of the pyramid as x. They try to work this out in your groups. Okay? On the second page of the handout here, Okay. Draw the diagram for the pyramid and for the stick, and it's their shadows. Mark the given quantities. And
ครับนักเรียนนะคำนวณเลย เดี๋ยวอาจารย์ก็จะเดินไปดูนะก็ได้คำตอบแล้วก็ยกมือได้นะยกมือให้อาจารย์เขาไปดูว่าถูกไหม
similar triangles. Just yes, but a simple one. Nice. Okay. Draw the diagram. Good. You have only a stick and a shadow. Okay, here. Very nice. So, here's your pyramid. All right, so some of you have already found and solved the problem. How many cubits is the height of the pyramid? How tall is that pyramid in cubits? How many? 320 is correct. Well done. But then the answer has to be given in meters, in today's units. 1 cubit is about 18 inches. 1 inch is 2.5 centimeters. How many meters is that? Your answer should be about 146 meters. Who has found 320 cubits tall? Please raise your hand. A few people, well done. Who has correctly converted this to meters and found 146? A few people, well done. Give yourself a round of applause. That is the correct answer. So, the Egyptians' pyramid was 146 meters tall, close to 150 meters.
Enjoyed it.
All right, one question here. Why do we have 230 plus 250 here? Where does that come from? The height divides the base into 2 parts. We know that the base is 500, so a half of it is 250. That's why we need to use 250 and 230 rather than the 500. So that's why we have 480 here. This is 4 to 6, is like x to 480. That's how we solve that puzzle. Isn't it math great? Math solved the problem that nobody knew before Thales. Thales was using mathematics to answer this problem. So that is a great story. Alrighty, so let's go on. Does anybody have any questions about this last puzzle? Any questions about that? I hope that you have a record of all of that in your notes, okay? So one of these other Greek philosophers was Aristotle, who created
ตอนนี้ขึ้นเรื่องใหม่แล้วนะเงียบได้
geocentric
เดี๋ยวค่อยคุยกันต่อ
theory of the universe. Does anybody know what is geocentric meaning? Geo is the Greek word for the earth. So that was the earth-centered model of the universe. Okay? Earth-centered. The Aristotle has created a model of the universe where the earth was in the middle of the universe. Earth was a sphere. They believed that it was a sphere. and it was not moving. It was just sitting in the center of the universe. And moon, sun, and the other planets were revolving around the Earth on a circular gears. That was the geocentric theory of the universe. That was the dominant view of the world for 2,000 years. But there was a problem with that the predictions did not agree. They initially worked, but then there were some discrepancies. There was retrograde movement of planets that couldn't be explained. I don't know if any of you are interested in astronomy, but if you look at the path of Venus, or some other planets as well, Mars, for example, it appears that it moves one direction, then goes back, and then moves to the other direction again. It is called a retrograde motion. So if we look at the Mars, for example, it appears that it starts moving backwards and then moves forward again. And this theory couldn't explain that movement. So they started to add epicycles to the Venus's and Mars's trajectories, and they tried to bend it this way. So that was a problem. And another problem was that the calendar that was created based on this model was getting out of whack every 10 or 20 years. And it was important to know the exact time because the crop had to be planted and we had to know when the Nile or when to plant things. So that was very uneasy for people to plan according to that algorithm, to that model. So it had to be corrected every 10 or 20 years. And many people wondered, why is that? So obviously, the Greeks were trying to solve that problem, but they didn't find out the solution. That was the situation that was held true for over 2,000 years, because in the 3rd century BC, the Roman Empire took over the Greeks. They burned the Alexandria library that had all the collection of the math papers and
นักเรียนเงียบหน่อยครับตอนนี้จะเข้าเรื่องสำคัญมากเพื่อพิสูจน์ว่าโลกไม่ได้เป็นศูนย์กลางของระบบสุริยะแต่ดวงอาทิตย์เป็นเรื่องที่ Nikolaus Copernicus ได้พูดถึงนะตั้งใจฟังให้ครับเดี๋ยวจะมีคำถามนะตอนสุดท้ายครูจะถามคำถามที่เป็นรายบุคคลนะครับ Thank you.
So then the Greek civilization was taken over by the Romans. The Romans were not good at math, not as good as the Greeks. They burned all the books and proofs. And the Romans were then conquered by the Gallic tribes, and it collapsed. For 700 years, maybe even 800 or 900 years, there was dark ages. There was no science, there was no religion. And that was the state of the science as people knew it at that time. So we are going to zip fast forward to a little bit earlier times, closer to what we love, right? Your kingdom started in about 14th century. So 14th century, that is the time that we are going to talk about now. Okay? That was the great kingdom that gave rise to Thailand today. So that was one of these wonderful times for the Thai civilization. There were Khmer civilizations before. There was this Cambodia kingdom here with the Khmer civilization. If you remember, or if you know, Angkor Wat, for example, a great place where science was also used. But we are talking about 14th century now, our era. And we are moving to a different place in a different continent. Now we are looking at Europe. In Europe, there is a country called Poland. And in 1473, in the city of Torun, was born Nikolaus Copernicus. He turned out to be the person who was thinking about these discrepancies with the model of the universe. And he was very curious. He was a very talented young man, and he was doing a lot of things in his life, but one of his interests that he kept throughout his life was astronomy. He was an economist. He has made a change of currency. He was a medical doctor. He studied medicine for many years. He was a priest. He has duties as a priest. And he was also looking at the sky whenever he could. Poland today is a country in Europe, in Germany and Spain, France. This is Germany, this is Poland, and this is Italy, and this is Greece. Okay, so that's where we are going to move our attention to for the next few slides. So he was born in this city, and I am also from that city. I was born in Poland, right there. This place, I lived in my youth there. Attended the school there. I went to see Copernicus's house, and I have seen his book, Revolutionibus Orbium Celestium, where he explained the heliocentric system. When I was a small boy, I saw this book and I thought that it was incredible. I think that this is because of him, gentleman here, I became interested in mathematics. So this is my grandfather. I would like to think that. He isn't, I don't know for sure. But so this is where we are now. This is today's view of Torun. This is a big cathedral, Roman cathedral that Copernicus was baptized in. His house was right here, where his house is. And this is how the city looked like in 14th century, maybe 15th century. Now, the cathedral, this cathedral is here. His house is right here on that little street. And you can go there today. You can see the cobble street. You can see his home where he was born, and you can visit his museum there. That's a museum. So I've seen that when I was a young boy as well. And every time I go there, I like to visit that place as well. So that's very close to my heart. So this is a view of Torun. This is a town hall where Polish kings would sometimes reside, and Poland in those times had a king as well, very wise, very powerful kings. Poland would fight wars with Teutonic knights. Teutonic knights, they invaded Poland, and Poland had to fight with them. Copernicus was in charge of defense of a town against the Teutonic knights. So he had a very difficult times. He lived in difficult times. He had to do many things, had many duties, and yet still was always interested in stars. He didn't forget his interest. This is his home today. This is exactly how it looked 500 years ago. This is his home. His room was on the second floor there, and you can go and see how he played as a kid. And this is a cobblestone street here that he played as a kid. Once he graduated from high school, there was a high school in Turin, and when he graduated, he wanted to study at the Jagiellonian University in the city of Krakow, which is one of the oldest universities in Europe and in the world. So he studied there. He had the introduction to astronomy. And the astronomy in those days were taught according to the Aristotelian model of the universe. So he learned there that the Earth was in the center of the universe. And he has learned that it didn't work quite well. So he got very intrigued by that, and he wanted to find out why is that. He did a lot of studying on his own, because in those days, people were teaching the Aristotelian universe. So he couldn't find much help from people that were teaching the same thing. Looking for who to talk to that would have maybe a different view. And he made his own observations. He went on to study in Bologna and in Padua, in Italy, also very, very old and vibrant universities in those times. And he studied medicine and Greek language. He was translating Greek to Latin and vice versa. So he was a very wise man. And everywhere he went, he was talking to people interested in astronomy about those discrepancies. And he has created his own system. In those days, we are talking about beginning of 1500s, he had already an idea that the Earth is not at the center of the universe. Around 1510, he printed his first notes that is called Commentariolus. This is in Latin. In those days, it was written in Latin. But this is the commentaries in today's language. So in those commentaries there, that universe, not the center of the universe or the solar system is not the center of the universe, but the sun. Right? The spheres rotate around the sun. This was his idea, and he supported by his observation calculations. So he knew that Earth is not in the center of the universe. He discovered that Earth was the body around which the moon was revolving. If you remember the Aristotelian universe, the moon was one of those circles going around the Earth together with other planets and stars. he found out that this is just around the Earth, and the other planets move around the sun. So that is at that time that he already knew that the sun is at the center of our system, not the Earth. So he has a lot of duty, a very busy man, very active with other things, and whenever he had a chance at the night sky at the end of the day, when everybody else would want to relax and go to bed, he would go to the top of the cathedral and he would observe the sky. In those days, there was no telescopes. He was observing with his naked eye. He had some very simple tools that he would just make a note of the angles. And he was calculating positions of planets in relation to the other planets and stars, and trying to find out a model for that. So that was a really very hard work. Because of all his duties, he didn't have much conversation with the other scientists to share this. Just a few people that he would talk to when they came to see him, because he could go to other places to tell them about his ideas. But he published this Commentarius, and people would circulate this, and they were really intrigued by that. So they would come to him, to his place in Poland, far away from the centers of the civilization those days, because he was sent to a place that was in the middle of nowhere. And he would carry on with his observations and calculations. So this was the cathedral where he worked, and he would have a little observational tower there, and he would at night observe the night sky there. By the way, he's buried in this cathedral, and recently he was discovered, his grave was discovered, identified, so we now were able to reconstruct how he looked like at the end of his life. And when I saw that picture image, it was a computer-generated image, I was struck because he looked exactly like my uncle. So I thought that there must be some connection. I'm saying this lightheartedly as a joke, but that's how he looked like, similar to. So what did he do? He said, this is not true. The earth is not in the center of the universe, but the sun is the star around which the earth and other planets are revolving. He said that the moon is just revolving around the earth. He assumed that the other the stars are fixed, they are not moving. And that's really true, because even the Greeks noticed that the stars are never moving. The movement of stars is relative to the movement of the earth. So this is what he said in his discoveries. He printed his book, and this book is called De Revolutionibus Orbium Celestium. And this is the book that is in the Torrens Library. This is the one that I've seen when I was a little boy. So I've seen this book when I was small, and I was amazed. How can you discover something like that? So this was my reason for learning mathematics. I liked mathematics since then. And that also would explain, for example, in a very simple way, the retrograde motion of the planets. In this diagram here, you can see the sun is here. This is Mars. We can see the blue dots, Earth moving in its orbit, and the Mars moving in its orbit. And at different points in time, 1, 2, 3, 4, 5 shows different points in time, because Earth is moving at a different speed from Mars. When it's approaching Mars here, it appears that the Mars is moving upwards, this way. Both Earth and Mars are moving in this direction. But Earth is moving faster. So at this point, the Mars is looking like it is behind. So that's why it is this retrograde motion. It is moving backwards, but just our point of view. So his model explained that discrepancy. It was a very natural explanation. So Copernicus's model had advantages over Aristotelian model. Not only did Copernicus discover that this works, he also were able to calculate the distances to the other planets. And he was able to tell in great detail the accurate positions, lengths of orbits of the planets visible at that time. So Mercury, Venus, this is Earth, Mars, Jupiter, Saturn, and he was able to calculate the distances to those stars, to those planets as well. So this is his view of the universe. This is what he discovered. This is what he wrote in the book. And that book became a little bit mysterious, because if something is being taught for 2,000 years, you're not going to believe it easily, right? You'll want to have some kind of a proof that this is really true. Copernicus, in his book, showed and proved things. He calculated positions of stars. He invented ways of calculating of trigonometric functions that nobody else knew before. And his book became really text for astronomy. People who were interested in astronomy were using his book for these calculations. So for about 100 years, his book was banned by church because it was against the teaching of the church. The church was teaching that Earth is in the center of the universe. Nobody dared to disagree. And Copernicus, he was a priest. He disagreed. And his book was banned. So only some of the people who were not afraid of being punished were reading his book. Okay, so this is a very interesting story. But what we are going to do in this activity, if you turn the page over, we are going to do the calculations that Copernicus did to find the distance of Venus from the Sun. For simplicity, we are going to use astronomical units. The astronomical unit is a average distance of Earth from the Sun, which is about 150 million kilometers. So we will be using astronomical units, okay? So please turn over, and in your groups, please find the distance of the Venus from sun. Okay? So please calculate this the same way as Copernicus did. We are going to use, for simplicity, we're going to use trigonometric functions today. Copernicus has found a way of evaluating the trigonometric function values. They didn't have trigonometric functions in those days. But we are going to use trig functions for simplicity.
นักเรียนคำนวณเลยนะครับวันนี้เราเป็นนักวิทยาศาสตร์แม้ว่าการคำนวณสูตรต่างๆอาจจะดูไม่ยากนักแต่มันให้เห็นว่าคณิตศาสตร์เนี่ยมันช่วยมาได้ยังไงฉะนั้นอันนี้เราจะคำนวณระยะทางนะระยะทางระหว่างโดยใช้1 AU คือระยะทางระหว่างวีนัสนะกับดวงอาทิตย์นะถ้าเราหาระยะทางระหว่างดวงอาทิตย์กับดาววีนัสได้ก็ถือว่าประสบผลสำเร็จนะที่มาฟังเลคเชอร์ในวันนี้ครับเพราะอย่างน้อยเราก็รู้แล้วว่าระยะทางจากดวงอาทิตย์นั้นในภาษาดาราศาสตร์เราจะคำว่า1 AU หรือ astronomical unit ครับ
A question was about what are trig functions. Trig functions, do you know some kind of abbreviation for the trig functions that you would remember easily? Which is which? Trigonometric functions, these are the sine, cosine, and tangent, and so on. So these are trig functions. In a right angle triangle, if we have a right angle triangle, we have the two sides that are created by the right angle, and we have the hypotenuse. So we have the other angle here, which is given, and we calculate either sine or cosine or tangent. Sine is the opposite over hypotenuse. Cosine is the which is which? Cosine is the very good. Which one? Sine. Very good. Yes. So sine, cosine, and tangent. In this case, we can use sine, and then we can calculate. Right. Copernicus. It is close up, but this hopeful. Good news. Is that going? Good. Very good. Nice. Yes, excellent. So it looks like everybody's getting there. Now, today, here, we would have to calculate the sine of 46 degrees. This is opposite of a hypotenuse. We have sine of 46 degrees. It is not an easy number to find. We have today calculators to find this value, but in Copernicus' times, they didn't have calculators. They didn't have sine functions. He had to evaluate this number from his observations. He spent many, many years trying to find the values of trig functions. That was one of his advantages. But today, we can do this very easily with a calculator. So the answer should be about 0.72 astronomical units, which is a little bit more than 100,000 miles. So if we... Did everybody get this number right? Congratulations. You have found the same thing as Copernicus did. Yeah! So that's what Copernicus did in his book. He was looking at this kind of calculations. So let's continue with our story unless there are any questions. Do you have any questions?
ใกล้จบแล้วนักเรียนฉะนั้นเราหยุดสักนิดหนึ่งนะถ้ามีใครถามคำถามก็ถามอาจารย์ได้เดี๋ยวจะได้พักแหละครับ
Are there any questions about anything that we have done so far? Because The title of our talk is about Nikolaus Copernicus and the scientific revolution. So we are going to look now at that scientific revolution part. Does anybody know what scientific revolution is or was? What do we refer to as a scientific revolution? A scientific revolution is when we change our way of seeing things in a dramatic way. For example, changing the idea that the Earth is at the center of the universe to the idea that the Sun is at the center of the universe. That's a dramatic change. That's a revolution. So that book really paved a way for scientific revolution to start because people took notice of this book and of this discovery and of this idea that things are not exactly what they thought to be. The things are different. If the things are different, that means that we have to change the way that we explain things by. And this is what happened after Copernicus. Erasmus Reinhold was one of the students of a friend of Copernicus who printed the book. Copernicus saw his book on his deathbed. It took about 30 years for him to complete that book, to be printed. And in those days, the print machine was just invented by Gutenberg in Germany. If you go to Germany, visit Mainz. This is where Gutenberg lived, and you can see the Mainz Museum, the Gutenberg's museum there. That's where the print was invented. Copernicus' book was one of the first books printed in this new system. So this gentleman here, he has used Copernicus' book and methods for
นักเรียน
calculating
เงียบสนิทเลยครับ
for calculating the trigonometric values of functions, and they were printed in this book. Then Tycho Brahe, which is this gentleman here, he was a very interesting fella. On that picture, you can probably notice that he has a golden nose. It is because he was believing in his ideas so much that he would duel with somebody else who would disagree with him. And in that duel, they used the spades, and his nose was cut, really. So he had a replacement for his nose made of gold. So he was a man with a golden nose. He created a very, very detailed calculations from the observations of the movement of planets and stars for a long period of time, for 20 years of calculations. So he really has created a beautiful database of information about planets, positions, and stars. And then, in the meantime, John Napier has invented logarithms. So they were used for simplifications of calculations. So that was one of these things that helped scientific revolution. But one of the biggest minds after that was Galileo Galilei. Please note, this is 100 years after Copernicus. he has invented a telescope. Copernicus didn't have a telescope to look at the stars. He was doing this with a naked eye. But Galileo Galilei looked at the planets with his telescope. What did he see? He has noticed that the Jupiter has 4 moons. And these moons revolve around the Jupiter, not around the Earth. Jupiter revolves around the Sun, and the moons of Jupiter revolve around Jupiter. So this was a first really big discovery in favor of Copernicus. Galileo Galilei, he believed that Copernicus must be right. He became a big supporter of Copernican theory. So much so that he was banned by church. The church asked him to renounce his idea, and he approved that maybe this is an idea, but he didn't think that it was just an idea. He knew that this is a big discovery. So he has noticed a lot of new things there with his telescope, and he was the one who invented the scientific method. You probably have done some experiments in your physics class or chemistry class, have you? What did you do there? You were supposed to create a reaction maybe, or measure some quantities, and then you had to see whether they fit a formula, didn't you? That scientific method from Galileo Galilei. The scientific method states that if we have an idea how something works, we have to test it. We have to make experiments. We have to take measurements, write things down, put down to formula, and see if it works. If it doesn't, that means that the theory is not right. That means that we have to adjust the theory, and then we take more measurements and we see if that works. If it does, that is a support for the scientific for that theory. So this is how the scientific method works. That is really described and started by Galileo Galilei. He was also a very, very interesting gentleman. He had many interests and was very busy, always doing some kind of measurements and calculations. So he was able to find size of planets and some other things, but this picture is an interesting one because it shows the size of planets and the sun. If this yellow ball here is the sun, these two are the biggest planets in our solar system, Jupiter and Saturn. Earth is the third planet here. You may not see it very clearly because it's very, very tiny. But that is how big sun is and how small the Earth is. So we had, with Galileo Galilei, discovery of the telescope, the astronomers were able to find a lot of new details confirming the theory here. Around that time also, a little bit past the Galileo Galilei, came Johannes Kepler, who was an astronomer, and he was using the tables of positions of stars that were created by the golden nose man. And he was able to form 3 laws of Kepler. Have you heard about Kepler's laws? There were 3 laws of Kepler. The first said that the planets are moving around the sun in elliptic orbits, with sun being at one of the centers of the ellipse. The second law said that as the planet moves in its orbit, the areas swept by the movement of planet in identical times fall. So the area of this S1 here is the same as the area of this one here. Since the planets are moving around the orbit, around the sun in elliptic orbit, it moves a little bit faster, closer to the sun, and a bit slower, further away from the sun. So the planet moves more or less like us here. It's slow here. So he discovered that these are cool. So he discovered that. And then the third law discovered was relating the period of revolution of a planet to the length of the major axis. And he found out that to period as P and length of the axis M, that P is proportional to M cubed. So that was his discoveries. Johannes Kepler, he used the data of Tycho Brahe because it was so excellent, it was so rich. He was able to find these relationships from that data. So he discovered these laws, and he stated that these are the laws of nature. And that was really true because they were able to calculate the mean distance or the major axis here and period, and the calculation confirmed that word is equal to m cubed in astronomical use. So that was really a great discovery. Descartes has created a Cartesian system that could be used to plot points describing 2 quantities, one horizontal axis, the other quantity on the vertical axis, and we were able to discover relationships from those positions. So geometry could be used to prove things. We were able to calculate the values of those positions. I'm going to fast forward here a little bit, but that is something that calculated now very easily in a pre-calculus class. How many of you have a pre-calculus class? In my class, you would have to calculate this relationship. Okay, so that is something we can find out. And then the next important person in the scientific revolution that came about 200 years later after Copernicus was Isaac Newton. So Isaac Newton was a British physicist and mathematician and astronomer. And he has revolutionized the way of mathematics, doing mathematics.
เสียงชักมาแล้วแสดงว่าอยากกิน
invented
แอปเปิลแล้วหรือยังหิวแอปเปิลเดี๋ยวได้กินข้าวกลางวันแล้วฟังอีกครั้งหนึ่งใกล้จบแล้วครับ please continue sorry
So he has created calculus, a new way of describing quantities and relationships between quantities. And using his invention, he was able to derive Kepler's laws using mathematics. So Copernicus has discovered a new theory of the universe. Then Kepler used Brycho's correct observations to discover laws that were already calculated using mathematics. But Newton has used mathematics to derive Kepler's laws from first principle. It has to be like that, Newton said. These are the laws that come out from basic ideas. So the idea that the Greeks have planted, that you have a few simple rules from which everything else follows, were used here in the most beautiful way. So I don't know if you know any story about Newton, but he has made all his discoveries, or major discoveries about calculus, about optics, about laws of planetary motion, during a pandemic. Did you know that? They had a pandemic in England in that time, and the schools were closed, the universities were closed. He was at home on his farm by himself, and he just had a book, a notebook. And he decided that he's going to write things in that notebook. He had mathematics, then he moved a few empty pages and wrote optics, and moved a few empty pages and wrote mechanics. And then every day, he would study a little bit by himself, write things down there. That's how he created his book, Principia Mathematica. That is one of the greatest books until modern times, until Einstein. This is where he discovered his gravitational law. I don't know if you know the story, how did he discover the gravitational law? But Newton liked to think about things, and well, as he was thinking about it, he was walking about his garden and would be thinking how to do things. He was tired. So at one time, he just decided to have a little nap, a little rest. So he lied down under a tree, and he just took a deep breath, and he fell asleep. And then some short time later, an apple that was growing on the tree under which he had his nap fell on his head and woke him up. And then, why did this apple fall on me? And it turned out that he had this idea that this must have been gravitational pull of Earth on that apple that pulled this apple onto his head. This is how he discovered the gravitational law. So sometimes
ครับอยากกินแอปเปิลแล้วใช่ไหมต้องมาอยู่เมืองไทยนั่งใต้ต้นทุเรียนน่าจะดี I told a student Newton should come to Thailand sit and sleep under the durian tree
Oh, that may not be that great an idea to sleep under a durian tree. If a durian fell on your head, maybe you would need to worry about this. But I don't know. Something
ครับกิตติทัศน์ครับต้องการ
something
ความ
is
ช่วย
not
เหลือ
showing here.
กิตติทัศน์ยังอยู่กับเราไหมมา
Okay,
แล้วครับ
okay.
thank you
So Newton in the 17th century, 18th century, he has invented calculus and other mathematics. He was an influential person for the scientific revolution. And in those days, by the time of Galileo Galilei, the Copernican theory was already established as the true way that that the universe works. So that was his proofs here were just a confirmation of that, following from the idea of Kepler and his laws of universal gravitation. So a few other things I would like to mention that happened. We are going to move a little bit forward, but one of these things that were also part of that whole change in a way of seeing things was the development of geometry. And in geometry was in those days used mostly by artists and painters to describe a realistic view of things, of the universe. In those days, nobody had a camera, nobody had a telephone to take a picture. The pictures were painted. One picture took sometimes many years to finish, or many days, or weeks, or months. But they would become very pretty. In those times, we are talking about 16th century still, they were inventing the scale, the perspective. The perspective was the way of painting that would center at one point in such a way that all these lines that in real life would be parallel would point. I don't know if you have ever looked at railway track. If you look at the railway, perfectly parallel. But when we look far ahead towards the horizon, what happens to these two rails? Meet. That's exactly what this perspective was. This idea of perspective was that these parallel lines, they meet. So really, they are not parallel anymore, right? Now that was revolutionary, it was at that time, but it turned out that two mathematicians, one a Russian mathematician, Nikolai Lobachevsky, who lived in the 19th century, and a Hungarian mathematician, János Bolyai, both were living at the beginning of the 19th century. They have created new geometries. New geometries. The geometry that we all know and study, it's called Euclidean geometry from Euclid. He described it in his book. Even today we learn Euclidean geometry. But they found out that there are some other geometries. Geometry where there are no parallel lines, for example. or geometry where through a given point and a parallel line, there are many parallel lines through that point to the given line. So that gave rise to different geometries. Now, a quick question. What is the sum of angles in a triangle? 180. Very good. But guess what? That's in Euclidean geometry. Now, if we have a spherical geometry, and a spherical geometry is geometry on a sphere, look at this triangle here. We go along the equator. Let's say that we start in Bangkok and we go along the equator a quarter of the Earth distance around. And then we move 90 degrees and then we go to the North Pole. And then we move down and go back to Bangkok at the angle of 50 degrees. So we have 90 degrees here, we have 90 degrees here, and we have 50 here. What is the sum of angles in the triangle? How much? $90 and 90 and 50. So it is more than 180. In spherical geometry, sum of angles in a triangle is more than 180. You can have a triangle that will have 90, 90, and 90. How about that? Okay? On the other hand, if we have a hyperbolic geometry, the sum of angles in the triangle is much less than 180 degrees. That's a possible future of humanity, a man-made, created space stations. They may have a shape of a torus. If you watch some sci-fi movies, sometimes you see that these stations have this kind of shape because it's easy to generate gravity in them. But in those spaces, a triangle may have 50 degrees, and 40 degrees here. How many degrees altogether in this triangle? 140, less than 180. There are spaces where sum of angles in a triangle is less than 180 degrees, hyperbolic spaces. It turns out that our universe can be very different. Gentlemen like Carl Friedrich Gauss, which was a German, and Bernhard Riemann, they invented models that would use hyperbolic geometry. And the surveys of the background radiation that is possible because of the space stations and the satellites reveals that our universe may not be Euclidean. What is the shape of our universe? It is yet to be determined. Here's your big thing. Maybe this is your thing. Okay? Maybe you can discover that. Maybe you can go in the footsteps of Albert Einstein, create a theory. Einstein's theory replaced Newton's theory. So we use now Einstein's theory, and we can explain how the universe works. It turns out that big mass like a sun or big star or black hole bends the space so much that even the light will bend. The light doesn't go straight there. So that's something that we still have to determine. But with all these developments, what Copernicus has put the foot for was all these discoveries. We have a lot of new satellites that are being sent out, collecting more data and more information. And we are finding more and more things because discovery. A deep space that the Hubble Space Telescope was able to discover some empty dot in the universe, the black sky. They turned out to have billions of galaxies that were created about 13 billion years ago. So at that time, this is the beginning of the universe. And not that long ago, a mathematician from Poland, Wolszczan, who was from the same city as I was, he has discovered stars with planets around them that look like Earth. At this time, there is a number of this kind of stars discovered, a number of those planets discovered. So it is possible that on one of those stars, somewhere there is a school similar to that one that somebody is learning about the universe there as well. But this is where the scientific revolution came to. Discovery that the universe is different from what we thought it was has allowed for a lot of new discoveries, has allowed for finding out many great discoveries in many sciences. And now, this is your turn. Now you have changed the future, to discover the future. What you are doing here in this school, you are learning the basics of sciences, the basics of mathematics, just like Copernicus did. You study these things so that you can make new discoveries. So maybe in 10, 5, maybe 15 or 20 years, you will discover something that the generations will learn about. Create a theorem that will be called your name. Make a discovery of something that nobody has heard about. So you have to be a part of the next step in the scientific revolution. Okay, so please remember, may the force be with you. Thank you very much for your attention. You've been very good students, very patient. I hope that you have learned something interesting here. But the best part is coming now, the quiz.
Just, Arthur, you can hear the silence. You know, I have been listening to a number of lectures by Dr. Arthur Gawker. This is one of the best to me, honestly. You know, every time Arthur we have new things to tell us. You know, I'm quite old. I retired from university more than 6 years ago. So you can guess how old I am, right? But this is a beautiful learning for me, too. I hope I look back at many of you. I can see the excitement. Really, I can see you now, too. Smiling, too. Very good. He understood us well. You know, I don't have to speak in Thai, right? No need to. Nah. Not his head. So I speak in English so Arthur can understand. Arthur started from the very, very beginning. And he said, in a universe, right? And he ended up with a new perspective or image of universe. My question is, I have to keep my promise. So I have written many questions here. We still have about 10 minutes to go. Would that be my time?
Oh, please.
Thank you so much. See, I'm retired, so I need my glasses. I go at the back. Let's start from the back. And I will just pick up those students who still want to face my eye. Very good, you face my eyes. How many galaxies? Your name is Pachari, right? So Pachari, correct? No? Oh, no, longer than that. Can you show your name? No, Panyapat, Panyatat, Chananyapat, very good. So Chananyapat, from what Arthur Gauger lectures, when we look at the universe, number of galaxies, approximately how many galaxies in the universe? ใน universe เนี่ยมี galaxy อยู่ประมาณกี่ galaxy ตอบตัวเลขอะไรก็ได้เยอะเพื่อนช่วยกันหน่อย Yes
More than 4 billion.
Right, a lot. Actually, 4 billion. That's the age of the Earth. Age of Earth, 4 billion years. But in the universe, there are more than. Actually, we don't know exactly. 1,000. No, more than that. 100,000 million galaxies, or even more than that. Now, I have to come to this way. Look at the student. I have to pick up a gentleman here. I think you look at me too, when you can answer. Now we come closer. What's the name of the galaxy? Galaxy, we are in.
Milky Way.
Very good. You catch up, Dr. Arthur, very well. Yes, you look at me too. You're lucky. Those who look at me, you are lucky. And actually, I'm very happy. Ajahn Krab, your students are very good. They understand. I came to Princess Jurapon here 6 years ago. 6 years ago. When you have the international ICT fair, right? Now I come, students can manage English excellently. An improvement. So next time we have more speakers. No need to have a translator. Now let's come back to Milky Way. How many suns? A star like suns. Star, né? Star. Approximately how many stars in the Milky Way galaxy? Okay, I can see from your search now. It's okay, you can search. It's how we learn things. Né? If we can't understand, we can search. What's your... Oh, yes, your friend helped you already. That's correct, né? So, in the Milky Way, students, if you couldn't remember now, your friend just told me there are about 100 thousand, millions. I mean, 10 to the power 11, 5 and 6. Stars like the sun. And you study about statistic probability, right? So most likely there would be more than one Earth, correct? And Dr. Arthur just told us that there is a gentleman from Poland too, who discovered extra planet. You see? Right, you're going to answer my question, like what is his name? See, Arthur, all the students, they're not worried about question now. You know why? They have a very strong internet connection here. But never mind, you can help. Yeah, your friend can help. What's the name of gentleman who from Poland who discovered? Yes, there is a hint there too. Yes, what's the name? You can look at on the screen.
Oh, it can't be Alexander Volsakansans.
Thank you very much. What's your name? Chiravit. Right? Very good. Where's your hometown? Your hometown. บ้านเกิดอยู่ไหน Jantaburi, do you have any durian plantation? A lot of durian plantation in Jantaburi. So how many trees you have?
Just like a 10,000 actually.
Oh, 10,000 durian trees. That's for export to China. Okay, I only have a few more questions, I think. Oh, you look at me. You want to answer the question? You know, in calculating, student เงียบลูกเงียบครั้งที่สองดีมาก In the calculation of the picture of the pyramid, pyramid, yes. And Arthur said in the old time we use the unit as cubit, right? In Thai, 1 cubit equals to the measurement in Thai we use normally. He showed his position. He said cubit is something, and he moved his arms and hands to show. So in Thai, 1 cubit is
ศอก
very good. She understood because in Thai we say 1 ศอกนะ 1 ศอก. There's 1 cubit. There's one thing you learned today, right? Very nicely. Do you learn like the Egyptian? I think I have probably 2 more questions. 2 more questions. This is about linguistic. เงียบลูกเงียบอีกครั้งหนึ่งจะจบแล้วลูกไม่คุยกันถ้าคุยกันแสดงว่าพร้อมตอบคำถามนี่นะ Arthur said mathematics rules R-U-L-E mathematics rules what does it mean in Thai
กฎของคณิตศาสตร์ค่ะกฎของคณิตศาสตร์
กฎคณิตศาสตร์ actually when you learn English more you can understand another version of this is good to learn English because he showed you have that slide about you can't enter, right? You can enter the place because there is a certain sign. Yes, so Arthur will show that later. So mathematics rules. กฎของคณิตศาสตร์ถูกต้องลูกวรัตยาถูกป่ะเขียนว่าชื่อเสื้อพี่สาวคนนี้นะเอามาถึงวรัตยาเป็นเสื้อของพี่สาว พี่สาวอยู่ที่นี่ตอนโคแสงยอดเยี่ยมเลยเนี่ยนะ See let no one unworthy in geometry enter here it's a mathematic rule นะถ้ากฎคณิตศาสตร์ก็อีกหนึ่งเช่น a square ถ้า b square ถ้า a square c square นั่นก็ถือว่าเป็นกฎอันหนึ่งนะอันนี้ก็เป็นกฎอัน another one it's like it rule mean it's a regulation that you can't enter here if you don't know geometry right another language that have see so there's a beautiful in mathematics นะความสวยงามของคณิตศาสตร์ในเรื่องภาษาด้วยเราสามารถใช้ได้หลายภาษาอันนี้หมายความว่า mathematic rule มันหมายถึงว่า I have to explain in Thai now mathematic rule ยังไงนอกจากกฎคณิตศาสตร์คร่าวๆตอนนี้ mathematic rule เหมือนก่อนตอนนี้อย่างสีจิ้นผิง rule China นะปกครองประเทศจีนใช่ไหมนี่คณิตศาสตร์ปกครองกฎระเบียบต่างๆว่าอยู่จะเข้าได้ไม่ได้ I just try to translate one now the last question who want to answer this question you raise your hand โอเคฟังให้ดีลูกอันนี้ไม่จี้ละDr. Arthur talk about Johannes Kepler right there are first second and third law that Kepler's law you look at me very attentively I think oh no I promise I want you to raise your hand can anybody explain the second law of Johannes Kepler raise your hand use this law yes oh you have that to help them that's very good who want to answer the question no explain it simply Arthur show everything when it move something like that so please anybody want to raise your hand to explain the second Kepler law โอ้ยจุฬาภรณ์ไม่มีใครกล้าเลยดีมากเธอดีมากครูมองเธอก็ I look at her she look at me mean she want to answer but I thought I keep it open but she want to answer that's very good
กฎข้อที่2บอกไว้ว่าในระยะเวลาที่เท่ากันพื้นที่ที่วัตถุเคลื่อนที่รอบดวงอาทิตย์จะเคลื่อนที่ไปได้มันจะเคลื่อนที่ได้พื้นที่เท่ากันในระยะเวลาที่เท่ากันค่ะ
หรืออีกในหนึ่งก็หมายความว่าไอ้จาก first law นะว่าการเป็นนะ ellipse ใช่ไหมนะ ellipse เป็นวงรีภาษาวงรีแสดงว่าไอ้ตอนที่อยู่ไกลกับอยู่ใกล้อันไหนจะเคลื่อนที่เร็วกว่ากันอยู่ใกล้เคลื่อนที่เร็วใช่ไหมหรืออยู่ไกลใกล้เคลื่อนที่ไกลเคลื่อนที่ช้า Okay thank you so understand very well I think this is just wonderful because I really feel confident with Princess Churapan Science High School and with your lecture like this just excellent นะอาจารย์ Birth that's her name Birth and